Given any real numbers x1, x2, y1, and y2, I can guarantee to you that this inequality will hold. Now this is called the Cauchy-Schwarz Inequality. It's not that well known. Also, there's a proof of it involving vectors, which I think is just a great way to introduce to people how they can use vectors to prove cool inequalities like this one. So, let's get into it. We'll first consider two vectors, so call them v and w. And we'll consider the angle formed in between them as theta. Now, we'll let theta be in between 0 and pi inclusive, or 0 degrees and 180 degrees, in degrees, right? So basically, if I had two vectors like this, then this would not be theta. This over here would be theta, because it satisfies this range. So that's a clarification. So we'll let vector v have components x1, y1. I like vertical notation like this. And we'll let vector w have components x2 and y2. Now consider their dot product. The dot product of v and w is equal to the magnitude of v, I wrote w, the magnitude of v times the magnitude of w times cosine of theta. Now we can literally get what v dot w is. This is equal to x1 times x2 plus y1 times y2. And the magnitude of v, well, this is equal to x1 squared plus y1 squared. The magnitude of w is equal to x2 squared plus y2 squared. And cosine theta is just cosine theta, right? Consider now squaring both sides. If we square the left-hand side, we would get x1 times x2 plus y1 times y2 all squared. This over here would be equal to, here on the right hand side, the square roots cancel out. So we just have x1 squared plus y1 squared times x2 squared plus y2 squared times cosine squared theta, right? Now, consider, the inequality is pretty much proven over here. Why? Well, this over here, x1 times x2 plus y1 times y2 all squared, this over here is just equal to this entire thing and then times cosine squared theta. Now we know that cosine squared theta is always smaller or equal to 1. So basically, this thing over here is just equal to this times something that is smaller or equal to 1. So basically, this over here is just a smaller version of this, basically. Therefore, we can conclude that this is always going to be smaller or equal to this. And the inequality is proven. Now, according to the notation, it's possible to have them to be equal. But when does that happen? Well, over here, observe. We need to have cosine theta to be positive negative 1 in order for them to actually be equal to each other, right? So, we must have the following. But when is cosine theta equal to positive negative 1? Well, this can only happen if theta is either 0 or pi, because it must be within this range as well. However, if theta is equal to 0 or pi, how would that look like in terms of vectors? Well, if theta is equal to 0, then we know that the two vectors would go in the exact same direction, right? Their angle formed is 0. So, we have v and w here. This would mean that w is a scalar multiple of v, and vice versa. V is also a scalar multiple of w. So if v over here is equal to x1 and y1, as written here, then w would actually be equal to kx1, ky1, where k is some positive constant. It's positive because they're moving in the same direction. Therefore, we can conclude that one possibility for equality is when there exists a constant k, a positive constant k, such that k times x1 and k times y1 would equal to x2 and y2. Like that. Now, what if theta is equal to pi? Well, this would look something like this. This is v and this is w, and the angle formed between them is 180, or pi. Now, W would now move in the opposite direction of V. So, again, if V is equal to x1, y1, then W would equal to, I'll write t x1, ty1, for some negative constant t, because it's moving in the opposite direction. So again, another case for equality is when there exists a negative constant t, call it that, such that t times x1 and t times y1 is equal to x2, y2, which would be w. So, combining these two cases together concludes that you can only have equality if there exists a certain constant c, such that c times x1 is equal to x2 and c times y1 is equal to y2, where c is some constant, right? Therefore, we have proven when this holds, when the equality holds. So, I hope you learned a lot from this video. You can see that vectors are a really powerful tool, and once you learn more, you can actually use them to your advantage for many different problems. If you found this video interesting, please do consider subscribing. Thank you very much for watching. See you later.